Welcome everyone to this webinar on planning and scoping LLM projects. Today's speaker is Prema Roman. Prema is a machine learning engineer here at Rotational with a wealth of experience in data engineering and machine learning modeling and AI and training transformer learned LLMs on domain-specific data sets. So she really does know what she's talking about when it comes to the project management aspects of doing LLMs, as well as just the day-to-day how to get these things tweaked and tuned and modeled and effective for your organization. So I think we're all going to get a lot of benefit from her expertise and her experience today. Just a couple of housekeeping items before we get started. There is a poll up, and if everyone wouldn't mind responding to that poll, we would appreciate it. There's also a Q&A button in your Zoom chat, so if you have any questions, go ahead and enter them either in the chat or in the Q&A panel. And Prema will pause, I think in the middle and then at the end, and I will pose your questions to her on your behalf so that we can get those questions answered. So, don't wait. Make sure you type your questions when you have them. That way Prema can address them, when she gets to the pausing place in the content. So with that, without further ado, Prema, I'll turn it over to you, and we're excited to learn more about planning and scoping LLM projects.
All right, thank you so much, Ben, and thank you all for attending today's webinar. We're so glad you could join us today, where I'll be talking to you about how to plan and scope large language model projects. So your mission, should you choose to accept it, is to become a data product manager. So you'll be tasked to get LLMs into production that have real business value for your organization. And in order to do so, you must talk to people, identify and prioritize use cases, and estimate impact metrics. So how can you be successful in your mission? So there are 3 principles. So principle number 1 is to adopt the product mindset. You will spend time on customer discovery to uncover use cases and prioritize the use cases that are the most valuable for your organization, and estimate impact metrics for each use case, which I will go over shortly and as to what these are. And from all of these use cases that you prioritize, select one small and valuable use case to start. Principle number 2, build with a production-first mindset. So the idea here is that back when data science became a thing and everybody was building machine learning models, a lot more consideration was given to building the state-of-the-art machine learning model that's the most accurate, that has the best performance. But then once it actually came to deployment, there were all sorts of problems that kind of resulted in a lot of these machine learning projects failing. And so one of the things that we have learned through our experiences is that really when you start a project, you should be thinking about deployment and thinking about how the machine learning aspect fits into a context of a larger software application that end users will be interacting with. And then third, kind of think about as you're developing these products and solutions, think about gaining experience and developing new capabilities for your organization. So it's not just about the modeling, but it's also just about building the expertise within your organization. So there's a few steps in that I'll kind of outline in terms of things that you can kind of do to ensure that your projects are successful. So step number 1 is to define a use case around a small but real pain point. And so kind of you want to take a sort of a wider, broader aspect in terms of like understanding the things that are going on within your organization. And really, at the end of the day, when you think about it, what do businesses care most about? And there comes down to 2 things. Objective number 1 is to increase revenue, and objective number 2 is to reduce costs. And so in order to address objective 1, the question that you should be asking yourself is, what new solutions can we build using large language models, given our expertise in the industry? And the question you want to ask to address objective 2 is, what business processes are currently inefficient that can be streamlined using large language models? And here's the thing. If you actually kind of think about objective 2 and try to address objective 2, it can actually help you also meet objective 1. And the reason being is that the best use cases for large language models and machine learning in general is to automate a lot of boring and manual tasks. Things that employees find very frustrating. They like their jobs, but there's always like parts of their jobs that are just really frustrating that kind of gets them away from the interesting things that they would like to do. And once you actually employ these machine learning models, then all of a sudden now your employees have time to focus on strategic activities, kind of employ their creativity to help them build new solutions that will generate revenue for your organization. So let's talk about identifying use cases. So all of this is, kind of comes down to customer discovery. You want to talk to everyone, within your organization. Talk to the functional leaders, talk to executive leaders, talk to customers, and talk to your employees. Ask them questions about their pain points, their workflows, things that they would like to have, things that they think that they, especially given some of the innovations that we have in machine learning. There are things that maybe before they kind of dreamed about and would be nice to have, and now it's an actual possibility. And so things like also just kind of looking at, kind of analyzing some of the business processes that you have right now, like what are taking too long. And, in terms of employee churn, sometimes if you're seeing like employees, quitting because, they're just frustrated, try to find out like what's behind that. You have, take advantage of exit interviews now. Like you can use large language models to kind of look through exit interviews and figure out like what are there some common themes that can help uncover where your issues are. And similarly with customers, you can do customer surveys, and maybe they talk through like their experiences, like things that they like, things that they don't like, and you can use large language models to extract insights from all of this data. So essentially, you want to think about becoming a use case detective. So there's look for some important signals inside your organization. So there's the needle in the haystack problem, and a lot of traditional machine learning models have been very good at pinpointing these. So think about like examples like where, especially as your organization gets larger, there's a lot more documents that you kind of put in your, say, SharePoint or Google Drive, and it becomes like this hot mess. And you're trying to find these documents, especially say there's only like a subset of these documents that you care about. Like how do you kind of wade through all of these documents and find ones that you're interested in? Well, these are things that large language models are good at. There's also the ever-flowing inbox. Like again, how many of us have to deal with like so many emails that are coming in, and it turns out that probably only 10% or maybe even less than 10% are emails that you actually care about. So again, here you can kind of employ some creativity and figure out how to say get alerts to like only the emails that you care about and kind of ignore the rest. And then there's also the case, as I mentioned, like there's inefficiencies that can cause your employees to be frustrated. They're doing some boring, rote tasks that are just really, causing them a lot of grief, and it's not helping them get to the work that they want to do. So, there are things like this that that large language models can also help address. And so kind of maybe kind of looking into like more specific use cases, a lot of hype has been thrown around for chatbots, but the reality is that large language models can do a lot more things than just chatbots. And in fact, like there have been problems with employing chatbots, even though they've gotten a lot better with using large language models. So some of the things that you can think about are automation. So we've already talked about like with document. If you have your documents in Google Drive or SharePoint, you can classify them based on like the contents of these documents, and that's and you can classify them based on specific areas. You can also use them for fraud detection. You can use them for text summarization. So for example, there are probably a lot of cases where your employees have to read through a whole bunch of documents to basically just to get only like the couple of documents that they actually care about. And what you can do is you can use large language models to summarize this text, so that then they can just read the summaries first to see, then dive into the documents that they care about. Large language models can also be used for sentiment analysis. So think about customer reviews, for example, and say, you're only if you have maybe a customer support team that's only a few people, and now they're having to service a whole bunch of customers. And how do they ensure that they can spot the cases like where customers are unhappy. And so you can use large language models to triage these reviews so that they can address the ones that are the most important, and then also they can glean other insights, and especially customers who are happy, or they can see like what are the things that they like, and they can kind of make sure that they're continuing to offer excellent customer service. You can also use large language models for information retrieval. So one way you can use chatbots is really for maybe an internal use case. And here, at least you don't have to worry as much about doing something that's catastrophic for your organization, because you can engage your employees and they can help inform where the chatbot is getting things wrong. They can give you that feedback, and you can kind of iterate over over these solutions. And then you can also use large language models for generating content, which probably all of you have seen. So now that we've talked about all these possible use cases, the question that I'll pose to you though is, do you actually need to LLM? And here's the reason that I asked this question. It's because just because large language models can be used to solve a particular use case doesn't mean that there aren't other ways to solve them. And especially for those of you who've kind of been in machine learning, for a while, know that there are other ways to solve problems, or even like just people who are data practitioners in general, right? So before you consider using large language models, ask the following questions. Ask if this problem can be solved by using business rules. There's sometimes old school business rules that you can use to solve a given problem. Next, ask yourself if the problem can be solved by using sort of advanced analytics, or can it be solved by using traditional machine learning models? And if you answered yes to even one of these questions above, don't go with large language models. And the reason here is that what you really want to do is, like, rather than kind of going for the hype, is you want to build the simplest solution that addresses the pain point within your organization. Because like we talked about the two objectives that businesses care about, right? There's the generating revenue and decreasing costs, and simpler solutions are more cost effective. They're also easier to maintain over time, because you want to think about not just deploying a solution and it's like one and done. You actually have to think about maintenance. And so really start small, start simple, and only add complexity if it's needed. The other thing that you also want to think about is large language models, as powerful as they are, they have limitations. They are not a foolproof solution. And I'd like to say that I kind of characterize large language models as sophisticated guessers and not calculators. So kind of to distinguish between the two, if you input 2 + 2, you get 4, and you're confident that 4 is the right answer, and you know that even if you didn't have to do the computation, you know that you can confidently be assured that you're getting the right answer. That's not always the case with large language models. As good as they've gotten, they're not always going to give you the right answer. And that's why you need humans in the loop, people who are going to, constantly like evaluate the performance of these models. And they get you a good amount of the way there in terms of solving your use case, but there's always going to be that, last mile problem that you need somebody, with domain expertise, who can, check and make sure that you're not steered into the wrong direction. And so really kind of thinking about AI as augmenting your workforce. All right, so we talked about impact metrics a couple of times. So here, kind of go through specifically what these mean. So the idea here is that you want at the outset of a project, thinking about what the end goal is, what is the objective, and you want to make sure that these are time boxed. Because again, like we talked about some of the limitations of what the previous, what we call like data science 1.0, where a lot of projects did not succeed. And what you really want to do is like time box your efforts. So kind of thinking about these as like MAD goals, which are M stands for measurable, A stands for attainable, and D stands for deadline oriented. And so the idea here is that what is the business effect on the organization? And so this usually relates to productivity gains or time or cost savings or revenue generation. So some specific examples are things like if you're experiencing customer churn, you want to maybe reduce customer churn by X% in say 6 months or a year from now or this time next year. You want to reduce employee churn, or you want to increase sales by a certain percentage. You want to reduce cost by a certain percentage, and again, like time box, all of these goals so that you have some way to measure the ROI on the project that you have taken on. All right, so I kind of talked through a lot of like use cases, and so before I go further, are there any initial questions that folks have?
Sorry, I was muted. So we don't have any questions from the audience right now.
Okay. All right, then I will continue.
Carry on. But yeah, if anyone has any questions, again, please feel free to type them into the chat or into the Q&A box, and I'm happy to review them and pose them to Prema when she pauses for questions.
All right, awesome. So continuing along, so step number 2 is to assemble a team to help with scoping. All right, so in a lot of projects, you've had cases where the people who are actually implementing the solution are not talking to the end users. So there's often a disconnect that happens where you have the end user that has some requirements, and then there's like layers of people in the middle who are translating these requirements and then telling the implementers, how to, like what to implement. And oftentimes what happens is that projects get derailed because if he had some key piece of information, we would have gone, the right path. And without the absence of that information, kind of take down the wrong path. And that winds up resulting in like this dumpster fire kind of thing. And so the suggestion that I have is you want to actually have people, the stakeholders and the people who are implementing the solution in the same team. So I want to just kind of take a quick kind of pulse and ask how many of you, if with a thumbs down emoji, have been in a project where there's all sorts of miscommunication and not knowing really like what the purpose behind like what you're working on, or like getting sort of wires crossed and having project failures as a result of this kind of like lack of communication. Yeah, so these are definitely pain points that we've all, I think a number of us have experienced. And so what I offer is for people to think about silos. Like there's a lot of silos and we want to ditch these silos. So they come in many forms. For a lot of us who have been working in the data field for a while, a common one is the database silos, the lack of access to data. How many of you have been on projects where getting access to data has been a major problem, or you're having to work with synthetic data while you're developing, and then somehow it's expected that your model is going to automatically work in production on real data? And the other kind of anti-pattern that I've sort of seen is there are teams that are kind of formed based on specialization, whether it's having your data engineering in one team and the data scientists in another team and the DevOps in another team. And you also have, maybe in some cases, like with data projects, you tend to have this kind of like an assembly line fashion, where one team is doing all the work for all of the different products, and then they hand off things to the next team and next team. And what tends to happen oftentimes, like when you do this, have this sort of this way of organization, is that the lines of communication are not clear. There's often a lot of misunderstandings. And if you kind of think about it, like even within your own specialization, like it's very easy to kind of miscommunicate, right? Communication is hard. So there's no need to kind of make these lines of communication even harder than they need to be. And there's often handoffs that are messy. And sometimes like, when you kind of hand off things to another team, there's always this thing like that other team is going to, like, say, pick up the ball, like even if you drop the ball, and there's kind of this like lack of accountability or responsibility, and it adds to a lot of inefficiencies. And so really the best, the projects where I've had the most success is like where we've had more cross-functional, collaborative environments where people across the different disciplines, talk to each other, they work together, they kind of have this, like, we're part of the same team, we're working to build these, this solution. And rather than kind of blaming each other, or, or like what tends to happen, like when teams are sort of siloed, you're kind of learning from each other. And the reality is that, especially say in the tech, kind of world, a lot of skills are, there's overlapping skills. So it really doesn't make any sense to sort of have specializations kind of be separated out when we can kind of learn from each other. And more importantly, you also want to be working with the business. So like one of the things that I would suggest is, even for those of you who are in the technical spaces, to kind of put your business hat on, kind of think like an entrepreneur, and like thinking about like kind of working to with with the business to understand what their pain points are, and ensuring that the products that you're developing for them is actually something that's actually addressing the needs of either the needs of the customers. So again, kind of coming down to like asking the smart questions and trying to understand each other and kind of like where you're coming from, and developing a culture of shared responsibility and shared understanding. And this really, for those of you who are leaders among the audience, like a lot of this can be mitigated by kind of setting the tone for, because oftentimes what happens with kind of the blaming thing is that there's failure is like inevitable, right? Especially like when you're working with new technology, but there's like ways to address that in a way so that it doesn't become adversarial. All right, so moving on to step number 3, create a data product requirements document. So what is a data product requirements document? It is similar to a product requirements document, for those who have worked, in kind of like traditional, software engineering projects, but with a focus on data and machine learning. So this is, again, something that you want to develop before the project starts. It's a structured document that kind of outlines some of the things that need to happen in order to get your large language model into production. And it is end to end, and it considers the user experience, and you put a lot of thought into like how the end user is going to interact with the solution. So the components of a data product requirements document is first of all the the purpose, what is the end goal, what are the impact metrics that we're going to use to say that we've actually gotten the ROI on this project. You also want to outline who the target users are, and think about the data sources and some of the engineering work that needs to be done in order to get this data, to use this data and applying for the solution. And then have an architecture diagram. And again, it don't have to, like, this doesn't have to be like very formal. It just has to be something that kind of gives you a roadmap into kind of like how the data is going to flow, throughout the application. And then ending with kind of like that user interface. And then you want to think about evaluation metrics. So, how would you evaluate the models? And then very importantly, you also want to have some sort of a framework around feedback and monitoring. So monitoring meaning like this is going to be part of some software applications. So you want to think about health checks, things about look at things that can go wrong, kind of anticipate and plan and prepare for that, and then incorporating end user feedback. Right. So there's going to be you'll kind of put the solution into production. There might be things that the end user see that's not quite right. Kind of learning from that and iterating on your solution. And so again, with with machine learning projects, it's essential to kind of take a cue from some of the software engineering principles, and which is that it's not just about the model, it's about the whole workflow and about the whole stack. And so you have code, you have data, and you have models, and you want to make sure that you are developing, and developing, as you're developing your solution, you want to be thinking about testing these solutions and then deploying into production. So sort of taking that software engineering mindset into your machine learning projects. And so really kind of thinking about all of this as a iterative and continuous process. So we have kind of like this development kind of area to the left and the deployment area to the right. And so you're kind of starting with the discovery and the use case selection. And then you create this data product requirements document. So now you have sort of your plan to start the project. And then you have the data ingestion and the model development. And then once you kind of have the solution that's in place, that you're pretty confident that this is the solution that you want to deploy, then you deploy this model. And then you have monitoring in place and then the user feedback. And the one thing that I want to kind of stress here is that this is sort of this continuous, this is like a, kind of like, step-by-step process. But it doesn't have to kind of go all the way to the end before you get the user feedback. Like there are things like, so example, like with the step 3, like this is like a, if you can kind of expand on it, there's a lot that's going on here, right? Like you're ingesting data, you have to do feature extraction and like feature selection, and then develop your models. And at any step of that process, you might discover that maybe the sources that you use, might not quite have the information that you need to, like there might be some issues with those data sources, and you may need to go back and ingest some other data, or there's some issues with like the feature selection process. And so you want to actually kind of think about incorporating user feedback at every step of the way, and you be doing things like demoing, like what you currently have to users, just so that it's kind of in line with their expectations. And it's okay that you have to go back and redo it, and rather than kind of spinning your wheels on like trying to get the best solution. Again, like because said, like it's better to kind of start small, kind of get kind of something that's going, like an MVP, and then kind of iterating on it. And oftentimes also the users might have some notion of like what they're looking for at the beginning of a project, but then their preferences might change, or there's things that they kind of realize like as the project is going along. So kind of thinking about these feedback loops. And so you don't really want to spend, I think kind of looking at it as, from an agile perspective, kind of do this work in short sprints. Like, so we'd recommend like doing some of these steps in like 1 or 2 sprint cycles. All right, so step number 4 is to choose the right LLM for the job. So there are a lot of different kinds of large language models. So there's kind of like 3 different flavors. There's the encoder only, the decoder only, and the encoder decoder models. So the encoder only models, are used to understand the meaning behind language. So we talked about classification and sentiment analysis tasks. So you can use these encoder only models. And so, some of the examples are BERT, just Silbert and Roberta. But the decoder-only models are used for generating content. So this is what ChatGPT is known for, where you kind of interact with it and it'll help you, write content or help you with your code. And then you have your encoder decoder model, which kind of do a combination of both. And then these are things, models that you can use for text summarization and translation. And so some examples are BART and T5. So now let's actually talk about third-party APIs. So ChatGPT has been, very popular, and there are people who are, using ChatGPT or using some flavor of like, open AI's models, but they are, can help you kind of ship your solutions to production quickly, but you have to consider the trade-offs, which is that you have to think about data security and privacy, because again, like now, if you're putting your proprietary data into open AI model, like now they have access to your data, and you can also it is possible, and as we've seen in the past, like where there can be breaches, and then you run into a lot of risks and because of that, and then you want to think about also the fact that somebody else is controlling the API. They can either push new features without notifying you, or maybe you don't have as much time to address, kind of like update your solution based on the new features that they pushed, or maybe they deprecate some features. And in fact, like there was a story about a few companies that actually went out of business because they were just wrappers around ChatGPT. And then once OpenAI deprecated some features, that pretty much caused their projects to fail, and they lost money. And then the third thing you want to think about is vendor lock-in, right? So if you kind of have now relying on these companies, you have no idea like when they're going to increase their prices, and the price can spike, and that can affect your budget in a negative way. Also think about like with some of these third-party APIs, you're paying by the tokens, which the number of tokens can be is a variable cost that you need to plan for, and you never know like where that spike can occur with how users are interacting with your system. So these are again just costs to think about and and plan for. And so one of the things that we suggest, like as an alternative, is to build domain-specific large language models. So where you can host and build your own models, and you can ensure that the data doesn't leave your environment, and you have control over the retraining cycle, and you can control the updates, and you have autonomy, and you can guard against vendor lock-in. And it's easier. It is actually easier to do than some of you may think, and especially in this case, you don't even necessarily need as much data, right? You can customize these by applying transfer learning, retrieval augmented generation, and by employing open source large language models, you can keep your costs down. So speaking of open source models, Hugging Face is the largest and most well-known repository, and has over 2,000 large language models, and including some of the state-of-the-art models. And the kind of the recommendation that we have is consider your use case, and it's easy to kind of go into Hugging Face's website and kind of do a search on the models based on your specific task that you're working on, and then select a couple based on domain relevance and the reviews, and then you can run short experiments on your data and evaluate the options and see which one works the best for you. So again, kind of thinking about iterating on your solutions. All right, so step number 5 is cost out the whole cost. So it is one of the things that people are thinking about is like, how much does it cost to use these large language models? And there's a lot of different factors that you have to consider, and this kind of hard to pinpoint an exact figure, right? Because it all depends, sort of on your use case um, and how many people are interacting with the system. And so what we did is kind of have a sort of like a comparison between, building your own solution and building, a solution, and then using a solution that's already been, kind of this, pre-built solution. And so there's kind of think about costs in relative terms. So, on some level, because you're building your own solution, you'll probably need to hire more data scientists and ML engineers. But even on the flip side of buying, using some pre-built solution, you need some data scientists and machine learning engineers who know how to use these, solutions. And then kind of thinking about the time to market, it is true that because you have to do some custom tooling, it will take a little longer to develop the solution versus say, some of the stuff has actually been taken care of you. But then you have to think about the long term, where if you have to deal with maintenance costs, let's say, again, like talking about like pushing new features, this has happened with like a lot of like software tools too, like where oftentimes like if new features are pushed or they're deprecated features, you might wind up spending, you might be able to get a solution deployed quicker using some pre-built solution, but you might at the back end pay for it by having to deal with, with these other issues. And of course, like with unseen price changes, that might affect, affect your, budget. And then vendor, lock-in, like, once you have that lock-in, you never know like when these service providers will increase their costs in a way that impacts your business. And then of course, like the security and privacy violations, that is a real cost, and that can really kind of make or break a business, right? So thinking about all of these trade-offs between upfront costs and long-term costs. So some other questions that people ask are about computer hardware requirements, and how many GPUs do I need? And the thing is that just because the foundational large language models required a lot of GPUs to train doesn't mean that your application will require the same amount of hardware. So I mentioned transfer learning and retrieval augmented generation. These can be used on top of pre-trained models to produce really good results. And we can attest to that. We built a solution for a client just using 12 megabytes of their data on a single laptop, and the laptop did not have any GPUs. And so again, kind of talking about GPUs, you say it really does depend. There might be some solutions where you do need, low latency. At that point, you have to consider GPUs. But then that's probably a good problem to have, right? Because if you're in that situation where a lot of users are interacting with your system, that means that you have a good solution, and you probably can afford to use GPUs. So it really kind of depends. And I still kind of stress the importance of like kind of starting small, and rather than thinking about like this is going to take a lot of resources, is to kind of start small and then building up, because oftentimes you might wind up discovering that you have, because of the revenue that you generated, that might actually help give you the budget to be able to then invest in GPUs for your use case. So there are also other factors to consider. It's not just the financial cost, right? So I don't know if like how many of you, if you've in the poll, answered the question that you're having trouble getting buy-in. There are things that you can suggest to your leadership about the opportunity cost, right? Like, so what are you missing out on by not employing large language models within your organization? So kind of making that case. And then of course innovation, right? The thing is that the large language models has kind of taken the world by storm. I mean, there's definitely a lot of things that can be done, and there are already competitors out there that are trying to find creative ways to use them to to develop new solutions. And so even though there might be some upfront monetary costs, kind of thinking about things from the long term, you can make the case that, again, like with this kind of starting with that sort of like iteration, kind of starting small mindset, there are ways to kind of get people to turn around and actually get the buy-in to start these projects. And along those lines, the thing that I would also suggest is make smart investments. So we sort of have this theme of like being very being kind of being thoughtful and mindful about how you plan these projects. So some of the things that you can do are leverage the talent that you already have. So the reality is this, that technology is constantly evolving and is going to continuously evolve, and you want to invest in upskilling. So, and then also when you're hiring people, don't hire based on just, what the specific skill sets that you have. You also want to be thinking about employees who are actually willing to learn and grow and develop new skills. And then the other thing to think about is also in kind of setting an environment for collaboration, across disciplines. And we already kind of talked about, some of these issues earlier in the presentation. And once you actually have this sort of a collaborative environment, then you kind of gain efficiencies because you learn from each other. And then, in some cases, if your organization, you really don't have the talent, you need somebody, hire a few specialists or consultants and have them train your existing staff. The other smart investment that you can make is to be mindful of the tools that you choose. So there's, a lot of, companies out there that are pitching, their new tools that will, that is going to be like the best tool, the tool that will solve all of your problems. But if anything that people know from experience is that there's never going to be the one tool that solves all your problems. And so you only want to buy these tools if the current set of tools are inadequate. And one of the things that I will also encourage, for people who are working in like larger, organizations, is that when you do have these like kind of try to kind of buy tools that are for the enterprise, like have your senior engineers be involved in the conversation to ensure that you're actually making the right investment. Because the worst thing that you can do is like have buy a tool that was sort of hyped up, and then it turns out it doesn't meet your expectations. The other thing that you can do is that there's actually a lot of open source tools that are out there right now in the market that are addressing kind of that data, the pitfalls of the data science 1.0 era, that they recognize that, in the traditional data science curriculums, there hasn't been a focus on software engineering. And so it's kind of challenging, right, to like have to do the data science work and then also now think about how to engineer the solution. And so there are these tools that kind of help you they do a lot of that additional work so that you can deploy your solutions as quickly as possible. So some of the ones that I, come across that have been, really good are Prefect, which is a data pipeline orchestration tool, and Streamlit, that helps you build like data products, like web-based data products that you don't actually have to know, how to like, build these applications yourself. And then the last thing, and I think this is sort of like a theme that I've sort of been talking about, is to be data agile. So kind of bringing in the agile mindset into data projects as well, where you build these MVP solutions and you ship early and you ship often, and then use the impact metrics as feedback to iterate, on your solution. Like, are we hitting our goals? Like, are there, where are we, if you're not, like, where do we have these, pain points? And so the one thing I will kind of talking through like all of these principles, and it might seem like this is a lot, and this is maybe like an ideal thing, and it's not possible. And what I will say that it is possible, and I will share with you a story, which is in a previous life, I worked at a financial services firm, and we sold historical stock market data products. I was hired on as a data analyst, but soon after I started working there, I kind of realized that they actually really needed more help in the software engineering area of the business. And kind of coincidentally, my boss sort of had the same idea of like, ask me if I was interested in learning software engineering. And I said yes. And he trained me to be a software engineer. And so through the course of the time that I was working at this company, when I came there, the company was selling US stock market data, futures data, some options data, Toronto Stock Exchange data, and the London Stock Exchange data, and the Deutsche Börse. And over time, we expanded our data offerings to kind of cover more of the European market. We expanded to Asia. We expanded to Australia. We significantly increased the number of products that we had within the futures. Within the futures product, we enhanced our options products. We were one of the earliest adopters of the cloud, and we built cloud-based solutions of our product, and we modernized our delivery solutions. And the one thing I'll tell you throughout this entire time is that there were a couple of people who came and left, but our entire engineering staff headcount did not change. And I want to kind of pose a question here and have people venture a guess as to how many people were in the engineering team. You can post the answer in chat. Or, all right, so 10 people. Anybody else want to take a guess? You can throw a number out there. It's anything crazy or not crazy. It's all right. So the answer is 3 people. And so here's the reason why. The leadership set the tone, fostered an environment of collaboration. People, the 3 of us kind of worked, all the 3 engineers who worked throughout the course of the time that I was there, came from very different backgrounds, but we all learned to work together and we learned from each other. And so we were able to very efficiently scale up and deliver all these solutions to generate, value for the company that we were in. And so really, kind of take these principles into mind and know that it is possible. And it is challenging, but it is possible if you kind of take this kind of mindset of collaboration and working together and making smart investments. And in terms of making smart investments, the smart investment that you can make for any of you who are sort of early at your AI journey is to engage with rotational labs. So as I mentioned, this is, we are a team of seasoned engineers who have kind of worked through these kinds of problems over the years. And we have delivered impact to the previous, organizations that we have worked, and we have delivered impact to the clients that we have worked with. And we can help train your existing staff to turn them into the unicorns that you are looking for. And so with that, I will summarize sort of like what we have talked about today, which is, so the key takeaways here are to become a data product manager. And so even if that's not your official title or you're not, part of the business, I encourage everybody within the organization to be kind of putting that product, having that product mindset, and become a use case sleuth. So trying to uncover use cases that you can use to deliver impact, for your organization, and identify impact metrics so that you're ensuring that you're actually getting the ROI on the projects that you have embarked on. Create a data product requirements document, assemble a cross-functional team, and start small, get to production, learn, build on capabilities. And the fact is that, every few years, you're going to probably see some new technology that's going to displace, the current technology. So really kind of thinking about building your capabilities, and also keep a tab on cost, and essentially embrace a future where humans are not replaced by AI, but are augmented with AI. All right, and with that, I will open up the floor for questions.
All right, our first question is from Steve Veldman. He asks, with regard to scoping, can you speak a little bit about managing stakeholder expectations, specifically setting realistic expectations regarding the capabilities and limitations of this technology?
Yeah, that's a good question. I mean, definitely you want to set expectations, and so my recommendation is to kind of try to see ways that you can quantify, the like, so, as you're working through your project, like you can kind of see like where the problems are, and you might like the problem, I guess, like with data projects in general, is that you can only automate away as much as you can, right? And so you can actually be as very specific, like uh like as you're working through the project, you can be pretty, like, you can kind of show, right, like where the model is um performing well and where it's not, and just kind of um recognizing that there's always going to be like that last mile, kind of issue, and um, really kind of be as specific as you can with like um, the issues that you're facing, and then there's ways to kind of like, and then kind of informing them that as they kind of learn, at the end, like based on how the model is performing, you can kind of use that to say improve over time.
Excellent. Our next question is, for the open source tools, we mentioned Prefect and Streamlit. The audience member would like to know about Gradio. Do we not recommend Gradio, or do we just not mention it? Have we not used Gradio? Do you know anything about Gradio?
I have not used Gradio. If I were to look into it, like I could probably have an answer for it. In fact, like there's actually probably a couple of other tools that come into mind as well. Like there are actually a lot of other companies that are innovating in this space, and so I would definitely look into that. But the only reason I sort of mentioned Prefect and Streamlit is because I have experience using those tools, um, but that doesn't mean that there aren't other solutions that exist.
All right, and the last question involves the pre-release of the ebook, which has actually an example of a data product requirements document. So the first thing I'd like to say is everyone on this call will receive probably a pre-release copy of that ebook. And Michelle, you will also receive the recording after the webinar as well, and we will soon publish that on our website. So if you guys want an example of a DPRD, there is one in that ebook. The ebook talked about a genre detection model to detect charismatic language. Internally, we've been referring to that as our anti-hype model. So Prema, I guess, are you interested in talking about that project, talking about what LLM model you're using to implement, like what's some of the project management considerations on that project?
Yeah, so I mean, we're just actually starting the project, so we don't actually have any specific models that we have tested out yet. But so what I would so sort of like the plan that we'll put in place is to like first see if there are data sources out there that we can kind of use to detect, say, like charismatic language versus like not charismatic language, or so with the idea of like either that there are data sources that are available out there, or if there's ways that we can kind of creatively like get this data, and then obviously like then kind of mentioning Hugging Face, for example, like that, that's an area like where we can go in and find some models that we can use, or kind of read the literature. Like if, I tend to do a lot of like research around, kind of like these topics, and then usually sometimes through my research I might find other models that are out there. And um, this is like an example of like a classification task. So that's something that I would like, if I were to go, if I would probably go to Hugging Face and see like if there are large language models that are suitable for classification. The other thing is that there might be also like research papers that actually talk about this. And in fact, like I think there are a lot that are out there. And so kind of reading through some of the ideas that are presented in these research papers kind of get some sort of like ways to like implement some of the ideas that are suggested in these research papers. And then next, like we'll kind of like have kind of a plan for like how you ingest this data, and then trying out like again like the whole thing of like experimenting with like a few different models, evaluating these models, and then kind of looking at like where the models are struggling, like what are some of the things that you can do to address those issues, and kind of then using sort of that knowledge that we gain to kind of iterate and improve on the solution.
Excellent. Well, thank you so much, Prema. We have a lot of thank yous in the chat. Before we sign off, I did just want to mention that if you would like to schedule a brainstorming session with us to go over what kind of use cases for AI and generative AI you might have in your organization, or what organizational transformation might look like for you, there is a link in the chat, both a long link and a short link, where you can schedule a call with us, and we'd be happy to discuss your specific AI initiatives for this year. Thank you again, Prema. It was an excellent webinar.